Hello guys, I hope you are doing well. In this video, we'll be looking at another question under this playlist based on all that we have studied so far. If you are new here, we've gone through all of probability, starting from the basic terms even to expected value, and then now we are solving questions on what we have done. So this question here says a random variable x has a probability distribution given by this function you see over here, where x is 1, 2, 3, and 4, and then c is a constant. You have to find the value of c and then compute these probabilities over here. So at this point, you can pause and then kindly go through yourself and then come back so that you look at how we'll be doing it together. Okay, so from the question, we know that the function is given by p of x being cx, where x ranges for this value and then c is a constant. And the first one says we have to do what? Find the value of c. So in finding the value of c, we know that this probability mass function is defined for all of these we have over here, right? So it is defined for p of x being equal to 1. And remember, one of the conditions for any function at all to be a probability mass function is that the sum of the individual probabilities should be equal to 1. So we add it to that when x is equal to 2. That is our random variable. And then when our random variable is equal to 3. And then when our random variable is finally also equal to 4. They should all sum up to 1. Now let's evaluate the various probability distributions. So we have probability of this random variable being equal to 1. From our function over here, it says it's cx. Is cx, right? So we are using that to evaluate that over here. So that is going to be c, the x now becomes 1, you see, then plus this also gives us c2 plus c3 and then plus c4. We are saying it should be equal to 1. If we evaluate this using the little algebra, we know c times 1 gives us c, and then c times 2 gives us a 2c plus 3c and then plus 4c, all giving us 1. The coefficient of 1 here, 1 plus 2 gives us 3, 3 plus 3 gives us 6, then plus the 4 gives us 10. So all these here should give us 10c plus 1. And making our c the subject, what do? We divide both sides by 10. That is equal to 1. So we divide both sides by 10, you see, and upon division we will just be left with our c. So our c is equal to 1 over 10, you see. So the constant we are looking for is actually equal to 1 over 10. This implies that the probability mass function is rather equal to 1 over 10x, you see. And it is defined for x equals 1, 2, 3, and then 4. So we have to take note of this. Hence, this is our c. Alright. So let's look at the next question. The next question says we have to compute the probability when our random variable is what? Between greater than or equal to 4. So greater than or equal to 1, but then less than 3. Greater than or equal to 1 but less than 3. So how do we evaluate such a probability? So let's take note that x should be greater than or equal to, you see. So for x being greater than or equal to, it implies that for p, for probability distribution of x being greater than or equal to 1 but less than 3, it is equal to the probability distribution of, first of all, it should be greater than or equal to 1. So it means 1 is inclusive. So the probability distribution of our x being equal to 1 plus greater than 1. So we have probability distribution over x being equal to 2, but it doesn't include 3 because the condition says it should be less than 3. You see, so this then means we have to solve for the probability distribution for the random variable x equals 1. You see, and remember from the previous page, this was the probability distribution. The probability distribution of any random variable within the range you have been given, it should be 1/10 of the x value. All right, so substituting that here, we are going to get 1/10 of what? Of 1, because our x value is what? 1. Simplifying this, 1/10 times 1 just gives us the same 1/10. Then we solve for random variable being equal to 2. So we have 1/10 of 2, right? And simplifying, 2 divides itself 1, and into 10 how many times? 5. And that is going to give us a 1/5. Easy. So 1/10 times 2 gives us 1/5. So now that we have the probability of these over here, we have the probability of these two, that is this and then this. We now do our substitution and then solve. So it implies that what we are looking for, the probability of our random variable taking the values of greater than or equal to 1 and then less than 3, we are going to get from what we have written here, 1/10 plus 1/5. Alright, so this is now algebra work. 1 plus 2, giving us a what? A 3/10. Alright, so the probability that our random variable takes the values between, that is greater than or equal to 1 but then less than 3, is what? 1/3. Let's look at the next one. The next one says we have to find the probability that our random variable is going to take a value greater than or equal to 3. And even from what we have here, greater than or equal to 3 would just be 3 and then 4. 3 and 4. They are the only random variables that satisfy this condition we have over here. So greater than or equal to 3 should be 3 and 4. Hence, that is what we are gonna solve. So let me just paste that here, and then now we can solve. So if we have the probability of x being greater than or equal to 3, it means we are then going to look for the probability of it being random variable x taking the value of 3, and then the probability of random variable x taking a value of 4. You see, so we will then solve for the probability of this random variable, that is 3, and that is 1/10 multiplied by 3, which gives us a 3/10. Then we solve for the probability of our random variable being 4 as well, so that gives us a 1/10 times 4, which is what? 4/10. So it implies that our probability distribution of x taking a value greater than 3 is then equal to 3/10 plus 4/10, and evaluating that gives us a 7/10. No need to there's no way we can simplify, right? You can even write that decimal. They are all accepted, right? These are the 2 questions relating to this section of the video. Thank you very much for coming this far, and I believe that you are understanding it bit by bit. If not, you can always go back to look at the previous videos we have done, especially the one explaining the terms and then the concept, after which you can then come back and then solve these questions with us. If the videos have been helpful, you can always choose to like, subscribe, and then comment at the comment section, and then let me know the various topics that are challenging to you, you would want me to do more videos on. Thank you very much, and then stay blessed. Bye bye.